action by displacement d, then we will say the work W is equal to force into displacement, isn't it? In the same way, if we apply a force in the y direction, and in y direction it is the initial position and this is the final position, and this displacement is d. So we can say that work is equal to force into displacement, isn't it? Also so the work is equal to force into displacement in the direction of force. This is a scalar quantity. This is a scalar quantity. If we say, what about the unit? The SI unit is Newton into meter. फोर्स क्या होता है न्यूटन में एंड डिस्प्लेसमेंट होता है मीटर में. देयरफॉर द यूनिट इज न्यूटन इनटू मीटर. ओके, this is the force, basic definition of the force of the displacement, what we have discussed in our class 9th and 10th. Now we consider the new situation. If there is some angle between the force and the displacement, for example, if we say that we are applying the force at some angle theta, and suppose this is a table, and on the table a body of mass m is placed over here. So, and it is the initial position A and B is the final position, and displacement on the table due to this force is D. So according to definition of the work, W is equal to force multiplied by displacement in the direction of force. So displacement in this direction, if we resolve the force, this is the horizontal component F cos theta and this is the vertical component F sin theta. There is no displacement of the body in the F sin theta direction. Therefore, the force in the direction of the displacement is equal to F cos theta into D, or we can say the work is equal to Fd cos theta. Displacement is a vector quantity. We represent this is a displacement D vector quantity. Force is also a vector quantity. Suppose this is vector F. We can write down the force is equal to F dot D. So the force, the new definition of the work can be defined as the dot product of the force and the displacement is called the work. So we will see that the work done by the force depends upon the angle between the force and the displacement. It depends upon the angle between theta. Suppose if angle theta is equal to 90 degree. It is a very important case when the force applied is perpendicular to the displacement. That is, they are force vector and displacement vector are perpendicular to each other. So in this case, work done would be 0. Why? Because Fd cos 90 and cos 90 is 0. Therefore, work done by this force is 0, isn't it? And if we'll take an example of the 90 degree angle. Suppose this is a force, this is a block M is placed over here, and we apply a force F at angle theta. If we consider this is a table and a block is placed of mass M, so this is F cos theta and this is F sin theta. But if we consider Suppose it is displaced by a displacement d, but if we consider the force mg, which will act always downward, when it is at the motion between point initial and final point, mg is always downward. Also, if we consider the normal reaction, the normal reaction is also the perpendicular to the normal reaction perpendicular to the displacement. Therefore, in this case, normal is perpendicular to displacement. Also, the gravity force is also perpendicular to the displacement. Therefore, work done by normal is equal to 0 and work done by gravity force is also equal to 0. So, these are the two important cases. Okay. Isn't it? So let's move to some another example in which case the work done will 0. Suppose there is a pulley. Suppose the height of the pulley is 1.5 meter, like this. This is 1.5 meter height, and a block is placed of mass m is at rest at the ground. Suppose this is ground. So suppose this is the mass 20 kg, m is equal to 20 kg. Now, so you have to find the work done by pulley. Work done by pulley in rising the block from ground to his head. Second, this is suppose first, work done by pulley in moving the block on his head in forward direction (20 मीटर). सो देखते हैं हम कि इसमें कुली जो है 220 kg मास को ऊपर ले जा करके अपने सर पे रखता है, मान लेते हैं, तो उसने कितना वर्क करना पड़ेगा। यदि आप mg को देखोगे तो mg तो लगेगा नीचे की ओर, डाउनवर्ड, इट विल एक्ट डाउनवर्ड, and the external force to lift the block you have to apply. If we are moving slowly the block from ground to the head of the pulley, so this is the displacement. So work done by external agent, that is the pulley, is equal to F external into displacement D. So displacement D is in upward direction, और force F external भी क्या लग रहा है, upward direction में लग रहा है. So what is the angle between F and D? The F vector F and D are in the same direction. Also F external will equal to m into g, that is 20 into g, and displacement is 1.5 meter. 20g into 1.5 is equal to 30 joule is the answer. Work external. This is the answer for question number 1. But what about the question number 2? Work done by pulley in moving the block on his head in the forward direction by 20 meter. Suppose this is the pulley and a block of 20 kg is placed on his head and he is moving in forward direction. So the block is moving also placed on the head of the pulley in forward direction. This is 20 meter, isn't it? If you will see, if you make the FPD of the 220 kg in the between motion, the 20g will act and F external in the form of the normal applied by the head of the person will act upward direction will equal to 20g. But this work done by normal will equal to 0. How would it be equal to 0? Because it is always perpendicular to the displacement. Normal is acting upward and displacement is in this direction. So the work done normal is 0 because theta between normal and displacement is 90 degree. So in this case, the work done by the person, by the coolie in moving by forward direction will equal to 0. Now we move to the next example. In this example, if there is a block of 2 kg placed on a rough surface where the mu is equal to 0.2. So first of all, you have to find first the force required to move the block slowly. Second, work done by F external in moving the block by 20 meter. Same, you have to find the work done by friction force in moving the block by 20 meter. Okay, so first of all, the force required to move the block slowly. If we make the FBD of this block, how many force will act? 2 kg or 2g will act due to gravitational force due to earth, and the normal will act upward direction, and the friction force will be, if we apply the external force, suppose the force is to be applied in horizontal direction to move the block slowly, F external should be equal to the friction force, and it is equal to mu into n. The value of mu is equal to 0.2, and in this case n would be equal to 2g. So 2 into g is equal to 4 Newton. So the minimum force or the required force to move the block slowly is 4 Newton. This is the answer number 1. For question number 2, the work done by F external in moving the block by 20 meter. If we consider this is the situation initially and this is the situation finally, this is 2 kg block and it moves by 20 meter due to this force in horizontal direction. This is the force which is equal to 4 Newton. F external is equal to 20 Newton. So the work done by this external force is equal to force into displacement, and the angle between force and the displacement, force भी इधर ही की तरफ लग रहा है और displacement भी इधर है, angle between them is 0, and therefore 80 joule is the work done by the force. But in case third, if we want to find the work done by the friction force, we will see this is 2 kg block initial position and this is the final position. If we see during the displacement, the friction will act downward, always downward, and this is the 20 meter displacement. The displacement of the particle from initial to final position is this. The definition of the displacement, as you know, that line joining initial to final position vector is the displacement vector. The friction force is acting in this direction and displacement vector is in this direction. The angle between them is 180. That is why if we want to find the work done by friction is equal to friction into displacement into cos 180, because this angle is 180. So the cos value of 180 is equal to minus 1. Cos 180 is equal to minus 1, minus friction is equal to displacement. The value of friction is 4 Newton and displacement is 20 meter. So the work done by the friction is equal to minus 80 joule. Isn't it? Now we move to the next example. In the next example, suppose this is the inclined plane at angle theta. Suppose there is no friction, that is coefficient of friction is 0. We have a block of mass m and the inclined length is h. This is the initial position, and when we release it from rest, it will come downward and will acquire some velocity. So in this case, you have to find first work done by gravity, second work done by normal. Okay, so work done by gravity. To find the work done by gravity, let's see. If there is an inclined plane, we will do in two ways this question. Suppose during motion, the block during motion, it is the initial position and it is the final position. So if we see, the displacement would be the line joining initial to final position, and this is theta. Suppose this is theta and this is h. If we want to find out calculate the work done by gravity, so we will see, and the gravity will act when the block in the motion, the gravity will act always downward, and the gravity force will equal to mg. So it can be solved. The work done by the gravity can be found in two ways. First, the force W is equal to force, displacement, and the force in the direction of the displacement. This is the displacement. If we apply the sine theta and we consider this the displacement, sine theta is equal to h upon d, implies that the displacement is equal to h upon sine theta. So this is the displacement. If we resolve the force vector in two directions, if this is theta, it will also equal to theta, and this is mg cos theta. Along the incline, the component of mg will be equal to mg sin theta. So the work done by gravity is equal to displacement multiplied by force in the direction of displacement. So the displacement is d, and the force in the direction of the displacement, we consider this is mg and this is the mg sin theta. So this is mg sin theta. So mg, and we will write the d is equal to h upon sin theta into sin theta. Sin theta will cancel out, and the work done by gravity will be equal to mgh. Okay. Normal and contact force are the component of the contact force. So let's see, if this is theta, suppose this is length h, we can say in the question it is given the height of the wedge is h. So we will say that when the block is coming downward, this is the net displacement. This is the net displacement of the particle. But if you see, first the work done by gravity. So gravity, if you see the gravity, that is mg. Mg is always acting downward, and this is the initial position, and this is the final position, and this is the displacement, and you will see that this is the displacement in the vertical direction and this is the displacement in horizontal direction. The work done by gravity is equal to force and the displacement in the direction of the force. H downward hai, H is always downward, force is always mg downward. So this is the work done by gravity, mgh. If you see work done by friction force, in this example, the value of the friction force which is acting in backward direction, the value of friction force will be equal to mu into n, and the value of n is equal to what? If this is theta, this is component which is equal to mg cos theta. Mg cos theta and n are equal, therefore n can be replaced by mg cos theta. Therefore frictional force, work done by friction force is equal to mu mg cos theta into displacement in the direction of the force. Because friction माइनस क्यों आया है? माइनस इसके लिए लिया है कि फ्रिक्शन फोर्स तो इस डायरेक्शन में कार्य कर रहा है और डिस्प्लेसमेंट इस डायरेक्शन में है. तो ये डिस्प्लेसमेंट कितना है? जो डिस्प्लेसमेंट डी है इसे निकाल सकते हैं हम साइन थीटा से. साइन थीटा इज इक्वल टू परपेंडिकुलर अपॉन हाइपोटेन्यूस. सो डी इज इक्वल टू एच अपॉन साइन थीटा. ऐसे निकाल लेंगे तो कितना हो जाएगा ये? डिस्प्लेसमेंट डी इज इक्वल टू माइनस म्यू एम जी कॉस थीटा इंटू डी इज इक्वल टू एच साइन थीटा. इजंट इट? ओके, सो ये कितना हो जाएगा? माइनस म्यू एम जी एच कॉट थीटा. दिस इज द वर्क डन बाय फ्रिक्शन. बट the work done by friction can be also written in another way. In what way it can be written? Suppose this is a particle m initial and this is final position of the particle and this is the base length and this is the height of the wedge. This angle theta, so we can apply this is the tan theta is equal to what? H upon L. Therefore H can be replaced as L tan theta. So the work done, what you have find, which is equal to minus mu mg cos theta H cot theta, can be replaced. You will see that work done by friction is equal to minus mu mg H की जगह रख देंगे हम L tan theta into cot theta into cot theta. तो बाहर से लिखते हैं इसे, वर्क डन बाय फ्रिक्शन इज इक्वल टू माइनस म्यू एम जी एच की जगह एल टेन थीटा इंटू कॉट थीटा. तो कॉट थीटा विल कैंसिल आउट एंड ओनली इट विल बी इक्वल टू म्यू एम जी इंटू एल. सो द वर्क डन बाय फ्रिक्शन, you will see the work done by friction is equal to minus mu mgl. Minus mu mg is the friction force and what is lg? L is the base length of the base, mu mg. In the same way, work done by gravity is equal to what? Is equal to mg into wedge height.